Hi, welcome to the video for Lab 1 for Math 215. And just really quick, so you guys aren't confused later, the way grading works in this class is there's actually an auto grader. So we as the TAs won't be grading anything. The auto grader will just look at your specific functions and variables. So you'll have a variable like first var, and you might have a function like average, I think is one of them. And what it will do, for this one, it will just test that it will look for this variable and make sure that the variable is equal to what it's supposed to be. And this one, it will look for the function and plug in a bunch of different inputs and make sure that the outputs are similar. So these are the only two things it will grade, and everything else that you have in your code doesn't really matter. So you can write whatever in your code. It will just only test for the functions and the variables that it looks for. Now, getting into problem 1, this one is pretty simple, just helping you kind of get used to Python. Just remember to use parentheses like you would in a graphing calculator. For problem 2, getting into functions, I kind of want to do a brief analogy really quick to help and demonstrate this. Let's make a function called just f. It'll take some input x, and it's going to return 5 times x. In regular math, we would write this simply as f of x equals 5x. But keep in mind that both of these definitions, as I call them, do not really do anything for us. I mean, they define something, but we don't get any actual outputs or anything like that. If we wanted to get an output for this, we would say something along the lines of f of 3, and that would be equal to 15. Likewise, if we want to do it in Python, the way we do that, usually with a print, unless we're doing some other way, we would do print f of 5. And that would actually get us our result. Or we could save it to a variable saying a equals f of 5. So that way we actually get a result. This is called a function call, and this is called a function definition. So back to problem 2. With our function, we have all of this kind of jargon that we want to piece together. And the last line is return w. And the way that I would kind of go about doing this at the very start is we have w, but w is actually already written in our code as something else. And so we can say return k minus 5 because that's what w is equal to. And we can actually get rid of that line previous, that w equals k minus 5 line, because we've already kind of adopted that rule into our return statement. Similarly, we can replace k with 3 times j, and we can replace j with I plus 2. And so just kind of eliminating variables until you just have one function in terms of I. Moving on to problem 3 with the rest of our functions. Hopefully you're able to sort through 1 and 2 on your own, but I'll go through part 3 in problem 3 because it's a little funky. So we have our combine function that takes input x and y, and we want to return the average of x and 3 times y. So this is an opportunity where this would be our function definition, but we would want to call our average function. And the way we would do that is just say average and then our parentheses and whatever we want to take the average of. And we want to take the average of x and 3 times y. And we already have a function that does 3 times y for us. So this is calling our average function with x, and I guess this calls our triple function with y, giving us 3 times y, and this calls our average function with x and 3 times y, returning the average of those two. So that's how you deal with function calls versus definitions and kind of putting them together. Now on to problem 4. Really quick, this deals with lists. It's the first problem that deals with lists. And whenever you're dealing with a list and you want to access something in a list, you'll use brackets. And you don't want to confuse that with a function where you use parentheses. Parentheses always deal with a function. Brackets always deal with accessing something or some things in a list. So for this one, the only tip that I think is really super useful is remember that if you want to access the last thing in a list, use -1. Rather than saying like C at 3 or C at 4, use -1, and that will always get you the last entry in a list no matter how big that list is. Now problem 5, maybe the hardest one. Remember that dot copy? I would read in the PDF more about that because I think that explains it best. Now to swap, say we have a list B123, and you want to switch it to 321. The first inclination would just be do this. This is swapping them, and we're doing -1 because we want to look at the last value. However, if you go through this sequentially, you'll actually get 3, 2, 3 at the very end. And we don't really want 3, 2, 3, we want 3, 2, 1. So what we can do to keep that 1 value is I'm actually going to set it in a temporary variable. I'll call it temp. You can call whatever you want to. And that's going to be my first entry. So this temporary variable is going to equal 1. Now, when we go to this one, our first value will equal our last value. So we have 3, 2, 3, and then we want to replace our last value with our temporary variable because that's where we saved it. So you set that equal to temp, and that will change to 1, and that's how you switch it. Kind of similar, an analogy is if you juggle two things, you need a place to put one of them while you switch the other. That's when you're juggling, that's the air. You throw one up, you switch one to the other hand, and then catch it. In this instance, our air is going to be our temporary variable, where we store something while we can switch the other one. Now, going on to problem 6, this deals with if statements. And really quick, similar to functions, it's very important that when you're dealing with if statements, you have indentation. So if I want to say like if x is less than 2, then all of the things that I want to fulfill because of this condition need to be indented. So if I want to do like 3 calculations, they'd all need to be indented. And then as soon as I want to go back to doing normal stuff, whatever the case, I would unindent and say return whatever. So remember to indent. This will be very helpful in all of your functions. Whatever you want to be in your function, you'll need to indent. Whatever you need to be in your if statement, you'll need to indent. And then next week, when you get into for loops, whatever is in your for loop, you'll want to indent. So just remember that. Now, this absolute value problem, it says accepts input x and returns the absolute value of x. And this quick note that they say is actually super useful. Now let's think. If we have x and we want to do the absolute value, if x is going to be greater than 0, then we don't need to change it at all. But if it's going to be less than 0, then we'll actually want to return -x, because if we have like -3, then -3 is 3. If we have -47, -47 is 47. And so the way to implement that would just be like if x is greater than 0, then we can just return x. However, and you don't really need to worry about 0 because 0 is pretty good on its own. Else if just else, that means if it's not positive, then it's going to be negative. So else return -x. And so yeah, this is this else loop saying if it's not positive, then it's negative, then we'll want to return the negative version of it, so it's positive in the end. Hope that logic followed. It's a little confusing, but this should hopefully help with it. Penultimate problem, problem 7, is talking about the indicator. And this is just saying we want to test if our n is between a lower and an upper. And unfortunately, we can't just stick an if on that and a colon and put that in Python. We need to have each like condition here can only have 2 of them. However, we can have as many conditions as we want. So the way that I would structure this is say if lower is less than or equal to n and n is less than or equal to upper, just for there. So that way we have 2 conditions, but we just need to make sure that both of them are true. And if both of them are true, then lower is also going to be less than or equal to upper because of properties. And so that's how I deal with that one, using and to be able to separate those 2. And then the last problem, problem 8, is something very, very similar. We want to return the larger of 2 numbers if one of them is positive, otherwise return 0. So we want to test if one of them is positive. The way that I would do that is just say if x is greater than 0 or y is greater than 0, we can use this or like we used the and in the last problem. So if one of them is positive, then let's say x is greater. If x is greater than, x is greater than y, so we'll want to return x. However, if the other situation is true, else we'll want to return y. And now we could put an else statement here that says if this doesn't work out, then we can return 0. But a helpful tidbit that I like to share is whenever you're running a function in Python and you hit a return statement, it will actually quit the code, jump out of the code and quit the function and just return. So if we went here and we returned x, it would jump out right there. It wouldn't test this else, it wouldn't test this else. So kind of, if you think about it, rather than saying else return 0, we can just say return 0. Because if it returns x or y, it will never reach this return statement because it will already have jumped out of the code. The only time it will reach this return statement is if it's going to return 0 anyways. So you can add that else if you want to, but this is another way of writing it. So that looks to be it for the lab. I hope this video was super helpful, and I hope you guys have a great week. Bye-bye.